Today, we are going to learn how to solve a navigation problem. First of all, we need to learn the prerequisite skills to have an answer to this problem. The prerequisite skills, which are the law of sine and law of cosine. Now, this is how the law of sine works. In a triangle, there are three angles and three magnitudes. The law of sine states the relationship between them is a over sine A, b over sine B, and c over sine C. On a side note, the law of sine works for any triangle. Here is an example for you to understand clearly. Given you that an angle A is 53, the other angle B is 30, and the length of A is 25 meters, what is length of B? As we learned before, the law of sine. A over sine A, B over sine B. Therefore, B over sine 30 equals to 25 over sine 53. Your answer should be around 15.7 meters. On to the next law, it is law of cosine. It is also used in a triangle and also applies to any triangle. However, the formula of the law of cosine is a squared equals to b squared plus c squared minus 2bc cosine a. For example, you are given a length b 54 meter, length c 37 meter, and angle a 53 degree. To find the length of a, you can apply the formula of cosine and the answer should be 43.4 meters. The prerequisites required, we can now solve the navigation problem. For example, let's say there is a boat and it's moving at a true bearing of 313 degrees. In my opinion, the hardest thing about this problem is trying to figure out the convention. When they say a true bearing of 313, what does that mean? True bearing means that how many degrees clockwise you're going of due north. Due north will be 0 degrees. So the boat is going at 313 degrees clockwise of that. Moving on to the next information given, the boat is going at a speed of 36 km per hour. That's straightforward, but it encounters a water at a current of 9 km per hour from west. Note, when we hear the word from means the vector is pointing in a direction towards the origin. Another word is to. The word to means the vector points away from the origin. As I mentioned, the water current is from west, so the vector is pointing towards the origin. But the question asks us to find the resultant velocity. What is resultant velocity? Resultant velocity is a velocity of an object relative to the ground. It is the bearing velocity. When the heading velocity or air velocity and effects the wind or water currents are added. And we know the vector don't have location, so we can rearrange the position of the vector of water current to make it easier to find direction of resultant velocity. After rearranging them head to tail, we are ready to find its resultant velocity. We can use the alternate angle to find the angle A, which means A equals to 43 degrees, and to find the magnitude of the resultant velocity, the law of cosine comes into play. The resultant velocity will be 30.1 km per hour. Now we have the magnitude, but what about the heading? The heading of the boat will be the true bearing of the resultant velocity, which means the heading of the boat is 313 degrees plus theta. To find theta, law of cosine comes into play. As we know, the relationship between the triangle is the sine rule. So sine theta over 9 equals to sine 43 over 30.1 will be 11.8 degree. The true bearing of the resultant velocity is 313 plus 11.8 equals to 324.8 degree. The resultant velocity of the boat is 13.1 km/h at a true bearing of 324.8 degree. After all of the studying, it's time for some fun fact. Do you think ship will sink in a greater depth in a seawater or in river water? The answer is river water. This is because seawater has more density than a river water because of its high salt content. This is why ships sink to a greater depth in a river water than the seawater. The Dead Sea has a high salt content and whoever falls into it can float. Hope you learned something from our video. Thanks for watching.
Created using Powtoon.